Just.
Oh, it's yours. Sorry, I'm not using mine. That's fine. Thank you very much.
Oh, no, wait a second.
Okay.
Also, I have to put there also the admin slides.
Okay. But you'll have this open while you're using this as well, so if you have any little problems last minute, you'll be able to. So it's just 2 sessions you have, is it? Just two speakers, is it?
No, 3.
3, okay.
But
you're getting this.
I'm waiting for slot 1. That's slot 2 and 3.
Cool.
That's the admin slides. It seems only 1 out of 3 is working. Ooh, I don't know if it's properly formatted. We are already late.
Okay, you've got a problem with that presentation.
Which one is that?
It's
Number 2, number 3.
It is number 2.
Number 2.
Which it, hopefully, I mean, it might be something like a font that's a specific font. It just says there's found a problem with the content. I've tried repairing it.
That's great. Okay. I don't know. Let's go again. Was number?
It is.
No.
And the other possibility is if he has a PDF version of it, that'll probably definitely.
We can download them.
Okay. It's either not supported file type.
Okay. But I don't. I'm copying them from here. Yes. Do that.
I'm even having a problem opening the PDF of this MD3.
Also.
Yeah, open with Adobe Reader. It could not open.
Let's see.
Because it's either. I've got my laptop here. We can try it now because that's
okay. That would be great.
Well, I'll try it on my laptop that's in the other room. See if it works. You need this. I use my room instead.
Okay. It seems we don't have a working PC. The cards are lying against us. What? We lost him. IETF legacy. Oh, geez. Why we have only? So let's see. There's 3, 2, 3, 3. So these ones are working. These ones are working. These are perfect. It seems we have. I managed to get them from the internet.
And today, have you tried them yet?
So this is the intro, and it works.
Oh, okay, that's great.
This is session 2. This is session 3. We are missing session 1.
So you won't be able to join us the hackathon?
Yeah, but not for 2 hours.
Was that the last one you waited for the chat?
Yeah, but it should be arriving via email, but it's not arriving.
I'll quickly check whether they work on here just in case.
The email doesn't arrive.
You please, yeah, sure.
Do you have any No.
No. Just trying to explain this. You can download it from the routing area open meeting from IETF. Sorry, 100. Like
Routing area open meeting.
I'm getting the same error message on this computer as well about those two presentations, so I think they're damaged or something.
Yeah, you can get it off the IETF 100 routing open meeting materials.
Okay.
How do I get it to last? So IETF 100 meeting material. Waiting for Google. Any other solution?
Can you do it through the website, just by clicking without directly So I don't know. Oh, here we are. So
Oh.
if we go to, so okay, it just took a long time.
If you go to
Singapore? No.
Yes, Singapore.
Okay.
And here it's routing area,
routing area open meeting.
open meeting.
It's just taking a long time.
Search for meeting material. Probably here, go down. Meeting materials.
Yeah, got it.
Sorry, guys. It's been from start to finish.
No, it's fine. It's just taking a long time.
Right.
It's working on it. Okay.
Routing area open.
Do a search. Routing area.
Where is this document search?
No.
No.
Wait, Control F.
Okay.
Routing area.
We're doing a search for dealer.
Dealer.
No, keep going. That's the money one.
Okay.
That's
So we have intro 1, 2, and 3.
should be it. Okay, sorry.
No worries. In the meanwhile, we can start projecting the other slides.
The first one.
This one.
This one.
Click.
Will the clicker work with that? Because this is showing as almost like in not presentation mode. Because I think you've got to scroll down. So I don't know. Oh, hang on, what's this? Oh, so that must be fit to page. Okay.
Yes, something that I click and we can see one slide per page.
Yeah. So it's this.
Perfect.
Yeah. So I just check to see how we're doing with it. Still nothing. I'm going to try and restart it. Maybe that's it. Maybe that's the first. Yeah, this isn't because I've refreshed it and it's not there.
No, it's low.
Ah,
Super
so
slow,
it's just
but
slow.
it's-
That's what it is. Okay, so I'll put you on your. There we go. Right, I'm going to pop into one of the other rooms. Hope everything goes well for you.
Yes.
I'll just wait till this is loaded, I guess.
Okay. Can we?
Oh, hang on. We need to.
We need to.
I can't actually duplicate this one, unfortunately, so I'm going to have to move it over to here. But you'll be able to see on this monitor here.
It is
No,
not
it's the wrong
connected,
side.
I guess. Ah, okay. Wonderful.
It's just one of the problems with this Michael of Dell.
Okay.
Still loading.
Is it F11 that's full screen? Where?
Well, I'm just using the.
I try to upload them now.
Okay, is it loaded on yours?
Oh, yes.
I think they're all right.
Yeah, they're all right. Yeah.
I will go
I'm just
in
going to
there.
go to the East-West Wing.
Sure.
Yeah.
Lovely. Yeah, really look.
Okay, I have uploaded them. Not loading.
I suppose one of the possibilities is changing the order of presentation. I don't know if that's something you would do.
It's the intro to the product, to the protocol. Okay, uploaded. Start. It's here. No, it's empty. Not yet. They are not synchronized.
So I think it's still downloading until that.
No, empty. No way. Error. Failed to load it. Wait. It's going. Oh, we made it. Where's the full screen?
It's the one, that one here.
Okay, let's keep like this. The clicker works. Oh.
Do you know what you want to do? You want to close this. And you've got the download.
Okay. Thanks. Okay, it seems we are ready to start. We have tens of engineers, but the technology is not helping. We'll try to be a little bit quicker than expected. So this is welcome to this joint meeting between CCAMP and Manet. I hope that was the right pronunciation. For people from Manet that don't know us, my name is Daniele Ceccarelli. I'm one of the co-chairs of CCAMP. Fatai, please stand up. Fatai is the other co-chair. You wanted to introduce yourself?
Sure. I'm Stan Ratliff, one of the co-chairs of MENA. The other co-chair is Justin Dean, who's right there in the front.
Thanks a lot. So, not well. Everyone should be. It was updated since last meeting, so please make sure you read it. Sessions. We will have 2 sessions. So this is the first one. Again, it's a joint meeting. We will have the CCAMP Poly session on Wednesday in this same room. This is the agenda for today. We will have 3 presentations, an introduction on the DLAP protocol from Stan, Justin, and Rick. And then we will have 2 presentations, one from Lou on DLAP diff serverware credit window and control plane based POS extensions. And then one presented by Rick on the possibility of moving traffic class ID to a new draft. So let's move fast to the DLAP introduction.
Okay. Hi there, Stan Ratliff again. Rick Taylor and I are going to kind of double team this presentation. the first slide kind of says it all. DLEP, what is it and why do I care about it? We think it's got applicability for control and monitoring. It was specifically designed to control and monitor RF devices, radios. Could also have applicability in microwave environments. And then even in some wired environments, there's been talk of using DLEP. And apparently at the last meeting in Singapore, there was a question of why isn't this in CCAMP? So here we are. We're trying to help out. I'm going to turn this over to Rick right now.
Thanks, Dan.
Before you start, timekeeping. We have 40 minutes. I would suggest to go for 20, 10, 10.
Yep, that's fine. This is actually a presentation I did in the Routing Area Open meeting in Singapore. So I'm going to blast through this pretty quickly because this is the second time these slides have been out. But it's more a case for there are CCAMP guys who don't really know what DLEP is. So quick blast through. So it's LMP according to Lou Berger. There we go. Okay, so DLEP has come out of the MANE working group. It's now we're trying to reach out beyond that. It's how do you do routing in dynamic networks when everything moves around really quickly and your link layer is based probably on radio devices where the links go up and down and so on. How do we solve the problem of making routing work well in these environments? First off, how do I form an adjacency? Seems like a really obvious question. You do the usual layer 3 stuff. Send some hello packets. Yeah, you're there. How do you maintain that adjacency? Well, you send some keep alives. That's cool. Yeah, we all know how to do this. And it works when your network looks like this. And it probably works when your network looks like this. And it probably doesn't work when your network is made of these things, which are, you know, complicated, modern, hybrid, UHF and SATCOM radio systems. You know, there's lots of things that can go wrong in this network. Because, there we go, radios have an environment that they're affected by. Atmospherics, interference. If you put them in a cave, it's not going to work so well. And also radio equipment commonly is fitted to things which move about. So, you know, your data center doesn't often get up and walk off. But when you're dealing with networks with radios in, you've put a radio there so that you can move. Good piece of advice for everyone here is if you can use a cable, use a cable. The wireless alternatives to cables are always worse. Okay, so a little bit of a digression here. IP has won. You know, we're just using IP over link layers. It all works great. Radio vendors are now moving to supporting IP across their networks. They do this using clever stuff to carry on their bottom end layers, but fundamentally they're designed to carry IP. And they differentiate by doing clever stuff to move the IP around. But fundamentally, they present an IP interface back to your LAN, and the clever radio WAN does its special source. Okay, and from a DLEP perspective, when we're talking about radios, we're not talking about your traditional point-to-point stuff. We're also talking SATCOM systems. We're talking these exciting meshing radio systems that are very popular in when you start talking about MANE. A lot of radio vendors will turn up and say, hey, we do a cool MANE system that, you know, solves the hidden terminal problem and does all sort of cool stuff. And also free space optical and microwave and that kind of stuff. So this is the key proposition from DLEP. This is kind of one of the takeaway points, which is, I'm going to read it out. So when dealing with links more complicated than wires, the link layer is already doing discovery and maintenance. So why are we doing it again at the routing layer? We're just wasting time and effort. And when your link layer is slow, that time and effort becomes important. So why not talk to the link layer and find out what it's doing? Bit of background, DLEP is the culmination of several previous attempts to try and solve this within MANE and in other places. Okay, so DLEP condensed. DLEP is a simple protocol that runs between your router and its locally attached radio, which we refer to as a modem, to allow the radio to tell the attached router when other nodes that are reachable across its over-the-air interface are reachable. So when they arrive and depart, including link layer information. So they are defined uniquely by MAC address. We're assuming a common layer 2 domain. You can include IP address information because that saves you having to ARP. And also it supports multicast. So if you've got multicast support, that's fine. It's there. Equally, not only telling you when destinations arrive and depart, it will also tell you when the quality of a link to those destinations changes. So if you've got two radio router pairs moving away from each other, the DLEP protocol will tell each attached router of those pairs that the link is getting worse. I'm making the assumption it gets worse as they drive apart. And vice versa, as they come closer together, hey, my link is getting better. The modem is already doing this work in its own control plane somewhere in the lower layers, and all it is using the DLEP protocol to present that information to the router so that the router might be able to do something cleverer with it. Okay, so how does this help? Well, by listening to, I'm going to read it out again because it's a good slide, I think. By listening to events from the link layer, routing protocols can react to the arrival and departure of peers in a much more timely fashion than having to poll. So we're trying to move to event-driven routing adjacencies. And also, if you have some idea of the quality of links, you can make far more intelligent decisions about how long should my timers be? What sort of cost functions am I going to apply to these links? You know, you can start to play some interesting games around link state routing, that kind of stuff. Okay, so I work for Airbus. We make aircrafts primarily, but we also make networks. Aircraft flying over a fixed ground position, it can take 45 seconds to go from horizon to horizon. Now, it would be quite nice if we could offload some of the data off the aircraft or perhaps upload some new data onto that aircraft. Okay, so we've got 45 seconds to do this, including both peers noticing each other, the link layer synchronizing, IP layer sorting out addressing, then top-level applications get round to actually moving the data. So that takes a very long time if you're relying on all these timeouts and so on. So trying to break it down, OSPF hello timers, commonly 10 seconds. So you're starting to cut into the amount of usable transmission, no, data transmission time you've got. And a point here is, particularly when you start to play around in these radio systems, you'll find a lot of application developers have tested this on their LAN in the office. And, 100 megabit Ethernet, it all works great. You then run it over a 19.2K modem. It rarely works well, but that's a slightly different issue. But it applies to routing protocols as well as to the top-level application stuff. With a radio system, you can hand-tune all your parameters to make them nice and fast. For donkey's years, people have been rolling out OSPF for radio networks, and they spend an awful lot of time standing in a wet field tweaking config options. And eventually it works, but it only works for that scenario. And as soon as you move them, you've got to start the whole process again. It's painful. A little point in here is that SDN sometimes seems to make it all worse. Every time I've tried this with SDN, the controller spends an awful long time thinking and then says, oh, I'll change all my switches to do this. Okay, that's good. And then you move something and the SDN has a head fit and has to start again. And you end up in this terrible loop. So for all you guys who are really interested in SDN in mobile ad hoc networks or networks with radios and dodgy links is a really interesting subject. And I don't have the answers. But if anyone does have the answer, please tell me, because I think there's something there, but that's a side issue. Key point to that slide is the end user just wants to do his day job. The poor guy who sat in that vehicle with that radio, be him a paramedic or whatever, he doesn't want to mess around, spend his time rebooting the router and fiddling around with the comms equipment. He wants to get on saving lives or whatever. So using DLEP, we should be able to skip ARPing. We should be able to do better things with the intervals. I know I'm going very quickly. These slides are out there. We can basically short circuit some of the stuff we have to estimate up front and actually take metrics from the link layer. Yeah, it's very cool, but it sounds like this only really makes sense in the radio world. Well, I'm not sure it doesn't, because link layers have got really complicated these days, as we well know. You're starting to tunnel layer 2 stuff. There's loads with virtual networking, LTE. That's doing some clever radio stuff. Wi-Fi. How much time have we all spent swearing at Wi-Fi on trains? It never works. We can do smarter things here. Domestic broadband. I know it's a fixed cable, but it It's never reliable. You never get the same data rate you got the day before. My home broadband at home changes radically whenever it rains. I don't know, it's something to do with the pipe work, but these things, moving link layers happen beyond the world of radios, and having the routing and the higher layers understand that the link layer can perform differently and getting that feedback back from the link layer is a powerful concept. So this is what's happening next in DLAP. I won't cover this because we've got a couple of presentations on it. The point of this talk was to try and reach out to the large community, which is why we're in CCAMP today. And here's a list of open questions associated with what cool stuff can we do with DLAP. Not really particularly relevant for now. That's it. Nice and quick.
You did well.
Justin Dean, Chair of the Manning Working Group. I just wanted to point out that some vendors have been adopting this, and I know multiple radio vendors that have put this in the radios.
Yeah.
I know that there are a couple router companies that have started to put this into the router, so it is something that's being adopted and moving forward within the community.
Absolutely, and I'll second that by the fact that I've spent a lot of the last 18 months on the phone to radio vendors and router vendors who want to know how to implement this. And it's being specified as part of big governmental projects and so on, as this is the way people see going forwards, particularly for the fuzzy edge of the network,
Okay, sorry. This is Fatajan. So as the co-chair of CCAMP, I'm really happy to see that you guys bring this kind of thing to CCAMP for discussion. So regarding the lab, I think actually it's a kind of protocol to exchange information between two ends of a link. So which is quite similar to LMP defined in CCAMP. Because LMP protocol can also be used to exchange information between a pair of loads. But actually, there are also some difference between these two protocols. So first, I think DLAB is only used for one single hop session, right? And other DLAB signals are run over TCP. But for the LMP messages are run over UDP. So these are difference. The second one is that LMP is called Link Management Protocol. So it can be used not only for link exchange information, but also it can be used for managing TE links. Yeah, so this is the second difference. So last one is that, so for CCAMP, actually for the CCAMP, we define the protocols for traffic engineering. So my question or my first comment is that for the DLAB, it is used for the LAN TE to address LAN TE problems or TE problems.
Sorry, can you ask that again? I didn't understand the last point.
Yeah, so I would like to double check if DLAB protocol is used to address non-TE problems or TE problems.
Lou, do you have the answer to this? I don't have the answer. Can I, while Lou is coming here, I'll answer an earlier point. The reason why DLAP is designed to run only across the local link and rather than across the network is because, particularly with radio systems, most of the radio systems run their own very custom over-the-air control plane protocols. And we were given very strong pushback from the industry to say, don't tell us what to run over the air, because it's a very limited resource sometimes, and we are not interested in that. Concentrate on letting us, the radio, tell you what we're doing just on the local link. Don't start to tell us what to run over the air, because we will not do it. Okay, they might run LMP over the air, which is great, and LMP and DLAP can work side by side, but they might run something special, and DLAP doesn't care, and that's why it's only focused on the local link.
Lou Berger is trying to respond to Fatai, who's distracted with the AD. So, there was a couple of questions there. First of all, surprisingly enough, I'm going to be talking in a little bit, but for the MANA side. I know CCAMP is familiar with me talking about things like LMP. And it was actually that experience that got me pulled into, or part of the reason why I got pulled into MANA and looking at DLEP, because it basically was doing a function that we did in LMP, but for a different type of network. And it was sort of the experience doing LMP and the notion of all the time doing common control that maybe there's an opportunity to do some common control here. So it was more from that perspective, from the TE perspective. Now, it so happens, one of the things that DLEP does is it gives you metrics to the destinations. So you actually get a whole set of parameters to every one of these endpoints. And while that's not quite the normal TE way of looking at it, well, we understand getting resource availability to ports, lambdas that may have different different bandwidth availability, different qualities, and so there actually is some similarity there. Now the metrics are composed in a completely different way, and maybe there's an opportunity to do something better there, leveraging the knowledge from CCAMP. Anyway, that was I think that answers the questions.
What are the type of parameters that can be carried over DLEP?
I'm sorry, say again?
What are the type of parameters that can be carried over DLEP?
You should have your co-chair answer, because he's an author of DLEP. I'm not.
In terms of the parameters that can be carried, right now what we have specified is data rates, both in terms of the maximum data rate the modem can deliver and the current data rate, or what he's doing right now. A view on latency that's on the link. And then there is an arbitrary and capricious parameter that was inserted because there's radio magic going on that we don't know about, that most of the vendors say, I'd tell you, but I'd have to kill you. I don't want to know. We call it radio link quality, or RLQ. So it's an abstraction of how well the link is or isn't working. It's viewed as it's not supposed to be looked at as a percentage value, but it really is. It runs 0 to 100, where 0 is the worst link you've ever seen and 100 is the best link you've ever seen. Now, that being said, we're going through a process right now with a couple of drafts where we're adding TLVs and adding additional data points. And so...
You missed 2.
Huh?
One other metric we've got is another blanket one called resources. Could be battery power, could be how much work is this unit doing. Yeah. Sometimes people want to route away from the battery powered things on the grounds that they're more likely to die than the things on mains electricity. It's a sort of catch-all one. And the other one, the one that went in quite late but has proven to be really popular, is an ability to say what the MTU is. So it saves you having to do PMTU discovery. So cheap to put in, made a huge difference in actual deployments.
In the end, this is traffic engineering.
Yeah. Oh yeah, it is kind of traffic engineering, but it's come from the MANA perspective.
Also with OSPFT.
Yeah.
Please, Deborah.
Yeah, this is Deborah, AD for CCAMP. I would tell CCAMP, don't get hung up, with that your charter currently says TE protocols. As we are seeing, everybody always, in the end, wants to do TE. There's always something that comes along. And so I would look at this more. Are you interested in this work? And then we'll figure out your charter later.
Yeah.
Okay.
As long as you approve it, we have no problems. Before we go, go Amy, then a question for Alvaro.
Okay, thank you. Amy from Huawei. So this is my second time to hear about this presentation, but I have maybe a deeper understanding. I hope it's correct. So I have several comments. The first one, I mainly work for microwave link. It's also radio, but it is true that the radio will have the commonality. For example, the bandwidth will change according to the environment. That's the same. But I see the requirements are quite different. because in our case, we are working for mobile backhaul, many in the telecom, so the devices are fixed. It's not moved in. And so we don't have such requirements to, for example, to have a fast discovery in a quite short time. And then the second comment I would like to make is about what kind of the radio feature should be supported other than the radio. Actually, in our case, since we are in the telecom network, we are asked by the operators to support the current popular protocols. For example, the LateConf or something like that. And so I see, although the link will have a similar feature, but the requests are different. And I also want to make another example about, we also have the protocols to exchange about the radio bandwidth. In ITOT, we define there's a definition on Ethernet ONM. I think Greg made this comment in last GG meeting. The bandwidth notification message is defined, used the Ethernet ONM to exchange the radio bandwidth. And it's currently include the nominal bandwidth and the current bandwidth, but it's only bandwidth, and it's widely supported by the current microwave vendors. It's used a lot. So that's several comments I would like to make. Thank you.
Just in response to your last comment, that's great, because if the link layer is already running these protocols defined by standards bodies, that's great. That means that information can just be reflected up to attached routers. So I think these are all compatible rather than competing protocols.
Yeah, I see. Because we are using the different protocols, but just to meet different requirements. Yeah.
So Dave Senecro from Ericsson. I'm actually fairly familiar with the work that Amy was just talking about in ITU, and it does present the bandwidth parameters in terms and things of degradation. What it doesn't do, however, and some of the things that they're wrestling with in ITU is how to do recovery or what to do with that information. And some of the contributions that have been brought into ITU have been trying to do this at layer 2. And you don't have enough of a picture at layer 2 to actually do something meaningful. So as you were going through, it occurred to me that this might be a very good mechanism to have a more holistic view of what to do. And perhaps not a subject for this venue, but it could be liaised or contributed over to
I will say when we define DLEP, we tried to be very careful about saying we're going to strictly define from a protocol perspective what data traverses the link, but we're going to stay completely away from what you would do with that. Now, in point of fact, the DLEP implementations that I've seen, there's signaling, this DLEP process picks up this data and then signals layer 3 to go do the right thing. Like for instance, on presentation of a new radio, a new neighbor, it will simply tell the routing protocols, you might want to go do some hellos, irrespective of your timer buckets. Go do it now.
Yeah, Justin.
Same thing on a removal. It's go drive your dead timers, but do it now.
Yeah. Right. Yeah. Some of the mechanisms that were being discussed over there were triggering G8032 link protection, which is very binary in its nature. And it seemed something more sophisticated was needed to make a more intelligent decision, which is pretty much what you're alluding to.
Just a second, timekeeping. We started at 20 minutes late. We will run at 10 minutes late. If I'm talking to the to manage chairs, agree, I would like to give more time to this discussion because I think it's more important to
yes, I agree.
Discuss about this and maybe postpone the DLEP extensions, if it's okay with you. Okay.
Can I have 10 minutes to have a DLEP conversation at the end?
Between 8 and 8.
I'm really looking to last call some documents or get some
same
direction.
here. I'm happy to merge with his 10 minutes and we can have a very fast conversation about some specifics of DLEP extensions and scratch my.
So I'm excited to see the interest in the working group in the work. and I agree with your statement about Dave's statement about how it works. This came about because in MAN-A we were doing the routing protocols, and we had stuff like drivers for certain Wi-Fi cards, and when we went off to a new one, you had to redo all that stuff. So it's just the interface that lets the routing protocols talk to the lower layer, lets lower layers talk to routing protocols, and then swap out the pieces. It really makes a lot of sense.
I think one of the things we came out with while we were working on DLEP was it really is layer 2.5. It doesn't talk about layer 2 intentionally, and it doesn't talk about what you do at layer 3 with the information. It's literally a way to get that layer 2 information to layer 3 without defining what you do with it when you've got it and how you got it. Is both of those things are out of scope. It tries to stay focused.
It's interesting. There's different perspectives on DLEP. I was just mentioning to Dave that DLEP is all about discovering Ethernet endpoints, and it has this ability to do what some people used to call augmented routing. So it also gives you some next level information with some IP addresses. But for me, the Ethernet discovery or the endpoint discovery is far more interesting than what it's doing at the IP level. So you get endpoints and you get resources to availability to those endpoints. That itself is a great function. And maybe coming from the context of this group of CCAMP, that information is more interesting than some IP reachability info.
Okay. You guys ready to slam your next presentations together?
Last question for Alvaro. Alvaro is the one that triggered this joint session. What is your scope? Make CCAMP aware of what is done in MAN-A. Ask CCAMP people to go to MAN-A and provide their expertise. What's your scope?
Alvaro Ratana, running the yes.
Yes.
Don't know the answer. Yes. So for a while we've noticed that DLEP and I'm going to say many other mechanisms in MAN-A are applicable outside the working group, and so in part is that get interest either to come this way or to go the other way. Right. So one of the things that Justin and Stan and I are going to do this week later is try and figure that out. Knowing that there's interest here, it gives us a point of conversation for us to figure out where to go or what to do going forward. It would be great if people came to MAN-A, right, to talk about this. There's of course other topics. So those are the things we need to consider.
Yes.
The fact of where the work would better fit. If we're going to develop this because there's interest here and interest in other working groups, well, we need to figure out where, right? Where people won't show up and discuss for 3/4 of a meeting something else, and only 10 minutes, something like this. We do want to. There is ongoing work in MAN-A on extensions, for example, that obviously we would like to continue, right? So if that is something that would be interesting here, along with other things, for example, then that may fit. So we haven't necessarily, we don't have a specific outcome that we want, because of course we didn't know how much interest there would be to start with. But mostly what you said at the beginning, to get the protocol better known in other places and to measure that interest so we can then see what the path forward is.
I work for a company for which radio business is 99%, so I couldn't be more interested. Lou, your time to present.
Thanks. I appreciate the Zoom level of this. There we go. I appreciate you giving me some extra time to or some time to answer some questions that we have that are very draft specific about how we proceed on the draft, because there's some different options available. The only bad part is I was far more interested in Rick's presentation than I am in mine. I mean, I want to be able to go forward, but Rick was going to talk about a new topic, and please correct me if I get it wrong, Rick. A new topic which was going to be right now, DLEP gives you information to a destination, but only sort of one metric. What about if you have multiple paths or multiple ways or multiple, maybe even just multiple queues going on, so that you could get different metrics to the same endpoint? And I thought that that was a really interesting application. I was just talking to Dave in the background, who's not paying attention, Dave. So I was just talking about Dave in the background, mentioning that I really had wished to hear your presentation. He goes, yeah, we need that for a protection application. So, it seems like there's some more synergy here than maybe.
These devices exist. I've had the manufacturer of these devices say, how do I make DLEP work like this?
Yeah, so I definitely am interested in hearing about that. But that said, I'm going to try to get some answers on my presentation. So first of all, what are we doing here? We have a couple of extensions that are talking about different types of flow control. So keep in mind that we're talking about packet level. Although we say packet, it's actually frame. Remember, these are really Ethernet things. Even though we have IP addresses, everything in DLEP, well, a lot of things in DLEP are really managed at the Ethernet level. So we have these routers, then we talk to these line systems, we talk to these modems, and we talk over a link. We call them sometimes media channels, right? It's the same stuff as what CCAMP has been familiar with. And we have the ability to do flow control. I can't point to it. We have the ability to do flow control in the direction of from the router towards the modem. Why aren't we only doing one direction? Why aren't we doing fully symmetric? Because in this world, that's where flow control is important. And we figured out how to do in the reverse, but there was sort of no real use case, so why make things more complex? And we have two different forms of flow control. One is really, really simple, and that is the pause extension. And think of this as X on, X off, or PFC if you're familiar with the Ethernet world, but you're doing it on a destination basis. And you also have the ability to do it not only on a destination, but a destination per DSCP. So one of the things that Rick talked about is that these radios are often IP aware, and the way they cheat. They while they're really forwarding on a MAC address, they also go look at the DSCP. And it is true that there are certain radios out there that actually even forward on IP addresses. I'm not. You guys know me more from the CCAMP world. I know more about the CCAMP world. I don't know about these radios. Never built one, never worked on one, never touched one. So, some of the people in the room may say, yeah, IP radios are really it, and your perspective in Ethernet is a little biased, but there's both markets out there. So we have pause, that's the really simple one. And then we have something which is a credit-based approach. And the value here is you can keep the line full. If you have a credit-based approach, the router can know what its different credit windows are and only send traffic when there's credits available. In the pause mechanism, you have to get a message that says stop. So what happens when you say stop? Well, you're not necessarily keeping everything full. With credit windows, you can be more efficient about your utilization. And also the routers can have a better idea of making sure that the right priority stuff is being forwarded onto the radio. So the big thing with pause is let's be simple. The credit is let's be as efficient as possible. Both of them operate on a MAC destination plus a DSCP basis. We had a bunch of discussion at the last meeting about that we would like to maximize the reuse of data elements, data items. What's a data item? We would call them TLVs. So we want to maximize reuse of data items between different extensions. And we had actually had a lot of parallelism in the two extensions, but not exactly reuse. And we talked about trying to optimize it. We took an action to do it, and we looked at it and said, are you sure? Because it feels like we have extra processing in this simple scenario of pause that, yeah, it looks nice from the control plane perspective, and it's nice you get, you saved a code point when we have 2 to the 16 code points available. Yeah, why not make it just easier for everyone to implement? The counterpoint is Well, if I have all these objects, it's easier to implement if I implement a common set. So there's a trade-off there. And the fundamental question I wanted to ask the working group is, which way do we go? So keep that in mind. That's going to be the punchline. So, I basically talked to this slide and said, it's nice to reuse ideas, and one of the ideas was actually Rick's, is that we should introduce something called a sub-data item, sub-TLV. Hey, we know that sub-TLVs are goodness. That's a good thing to do. But the identical reuse of data items between these extensions seemed not to be, from our read, worth the extra overhead in the simple case. Independent of that question, maybe I'll jump to that question and then come back. We have a question of how many documents, because we've ended up doing a bunch of core extension, like one core extension to the protocols, the sub data item. Another one is the concept of credit windows, and the last one is how do we identify them. And actually, I'm going to talk about this. I'm sorry, going. The next one is how we identify them, and the question is how many documents do we need? And do we keep this all bundled into one document? Do we break out into multiple? The other thing is that we said in the past in the working group, we've talked about is identifying based on Ethernet priority code point is an interesting use case versus DSCPs. And that would be a reason why you want to have these reusable objects, is so you could do that. So to convince ourselves that we actually had a viable building block approach, we did a definition for Ethernet PCP. And the question is whether we want to do something more than keep that as an appendix, as a notional thing. Making it real was actually really little work. It doesn't take a whole lot. Do we want to do that? So we came up with a recommendation. We think the sub-items, how sub-items work, that's a good independent piece of work that should be published. It's basically the definition of sub-TLV formats in the protocol. That's a core extension. It should stand on its own. The next is basically how credit windowing works, and independent of traffic types. And that would be a mechanism that itself wouldn't be an extension, but the extension would be when you use that together with a certain traffic classification. And so we think it's important that should be a standalone document, and then have a traffic classification definitely for DSCPs. That's what we've been working on. And if there's interest, also go do the Ethernet one. So there's probably not time to go too much into this, but I'd love some feedback maybe on the list. Or
Very quickly. Rick Taylor, very loudly. I did a bit of analysis on where we might want to use sub-data items, and following on from the conversations we've been having. The only place I can see where they really make sense is in the traffic classification data item.
the sub-data items?
Yeah, I can't
No,
find
we
any,
use them in PAWS. We use them in both.
but PAWS is using traffic classification data items. Really, that's my point. It's pretty.
So you don't want it to be a generic thing?
I would have a generic traffic classification data item that supports sub-TLVs.
Okay.
And so
Stan,
have
you
one.
had opinions on this in the past.
Yeah, I would vote for making the concept of a sub-TLV a generic VLF wide, because I can see things coming. There are some possibilities where we could use them.
Okay. Yeah, I don't have a strong opinion about that. I just, from my analysis, I could only see them really being manifested currently in traffic classification data items. But that's fine if you want to make another document.
I agree with you in the current incarnations. That's the only hard use case we've got for them.
But what I was going to say during my presentation, which we'll skip over, is I want to use that traffic classification data item for a third use case, which is when I have flows which traverse different paths across the radio network.
Let me show two slides, but before you walk away, what do you think about Ethernet? Should we be working on the Ethernet document, or should we just let that?
I would have that within the traffic classification document to say, here is the specification with a sub-TLV for DiffServ, and here is a sub-TLV for Ethernet.
They each need their own extension, because you have to know whether you're doing it based on DSCP or Ethernet. And given that they're each their own extension, why not just put it in their own document? And they're pretty thin documents.
Yeah. I mean, as long as we don't annoy the RFC editors by producing 101 documents of 3 pages each.
They
then
get paid
I don't-
by how many RFCs they
Okay.
produce, so, yeah. That's a joke. Looking to the chairs, do you think it makes sense to do the split that we have here? Should we proceed with this split?
I think so, yes.
I don't have a strong opinion either way.
Okay.
I think more towards the point of having too many documents. If there's going to be a use for having them split up, then I think we do it that way. If we're going to just split them up because there may be a use sometime in the future, then I don't think it's a good idea.
That would go to the document 1. Documents, the diffserv and Ethernet really makes sense to be in their own because they're 2 different extensions, and you don't want to have to point to one RFC and say implement this option.
Document 1 is the one document out of the group that I've got a fairly strong feeling about. I think it ought to be separate.
All right, so we're going to go, the next rev, we'll break this into 4, and we'll work with the chairs on how we name them. So now we're getting into
Can I
this.
just jump in? Can you go back one slide? I would like a document 5, which is traffic classification data item.
So that was the top level that we were not going to do, but that's okay. So we can break out traffic classification.
I suppose you could include it into 3 or 4 and refer to each other. in
So
some way.
here's the traffic classification data item. It's the one in blue right in the middle. The only difference between what we're doing today and making it generic is we would call, we would call, I'm going to come over here. This field, look at that field. We would have a flow control identifier, and instead you just want to make that a generic flow identifier. And that's actually where we had talked about that the last meeting. So we certainly can do that. I think we should talk a little bit about whether we really want 5 documents versus maybe put it into this credit window document, call it something else, because it's just a component that's reusable. Maybe the sub items, credit window and the traffic classification go in one document, which is just new data item document, because they're not any extensions on their own.
Yeah, that works for me. I tried a first pass at the Flow ID draft, and 75% of it's absolutely trivial, and the last 25% I don't have the answers to all the questions. It's the corner cases are really hard, and I would like some help working on it, but I think this is a good proposal to start.
Look through the details on this, what I call this discarded option, because one of the key things is we really wanted to do the work up front on the session part, and because we were doing the work up front on session and only a very little bit when an endpoint showed up, it meant that we reorganized the data a little bit.
Yeah.
And if you did it, if you distributed it, on one hand, it works more naturally for the objects, but it does the wrong thing. It puts the heavy burden of all the computation checks when the destination's up, so it makes it longer before you can send data.
No, I'm totally sold on that approach.
So please
do the
just
heavy
go through
lifting
this.
in the session initialization.
Go through the details of what's on this slide with the difference of calling it flow identifier and instead of flow control identifier. And if you're okay with that, we'll be in sync. If you're not, please bring it up on the list.
Okay.
So we'll go for a 3 document split and get some confirmation that from Rick that it serves his future purpose. And we're hoping we'll go to last call on this before the next meeting, but maybe it'll be after the next meeting. Now, the one last thing is I'm going to give a shameless plug for one of my co-authors. He's put out open source code on DLAP. And you can get that off of the MIT Lincoln Lab repo. And he is in a process of working on some of the extensions, the ones that just went through last call. And before I left, he had one of them almost ready to go last week. He was hoping to get it up before today, but I didn't get the email saying it's up, but look for it soon. and I think the second extension. This is the latency and multi-hop extensions he's working on.
Rick Taylor again, big thumbs up for that open source thing. We use it. It works very nicely. Pushed a couple of patches back to it as well.
Oh, great.
We might be interested in doing the lid extension stuff for it if he wants a hand.
I bet he'll take a pull request. Now, that said, I'm not involved at all in that code, so I can't speak for him.
It's if he's listening.
The last thing I'll say is we had two other extensions that I think passed last call. And I just wanted to know, have they passed last call?
I think so.
Okay. So the chairs say they think it passed last call. So I look for the shepherd write-up and that getting pub request. Thank you. I'm sure I'm over time, but questions? Thank you.
I'll go very quickly through this because Lou has covered most
I
of
was
it.
going to say, thank you, Rick. That's all we have time for.
Basically, really the primary thing I want to talk about is the link extension, link identifier extension. Those of you who've read it, there was some discussion on the list. There seems to be rough consensus that it's in good shape. Pushed out one last version today with the latest updates from Chatter on the list, and we'd like to go for last call, please, chairs. So that's my critical bit on that. This, get this off the meeting materials, read in your own spare time. This is about the discussion that Lou and I have just had about splitting out traffic class identifiers and trying to reuse them to talk about flows. I have a question which I'll take offline with Lou at some point and anyone else who's interested about whether the pause is actually talking about a local queue, which is different. So I prefer to have a queue ID, which is a different concept from a flow ID, which is why I've got that strange. It has queue ID. I need to go back around it again. But I couldn't remember whether it was in or not. Yeah, okay, good. That's it. It's quite technical. For those who want to know, we'll take it to the list and argue it. But thanks.
Thanks to you.
Justin Dean, just in terms of last calling it, I have to take a look at it again, but as soon as I do that, I think that's a reasonable thing to do. And me and Stan will talk about finishing the last calls up and pushing and doing the thing that Lou had talked about, because there have been discussions and documents revved, and I think we're at a point where we can do that.
Okay, thanks a lot, everyone. We are just 7 minutes late, so we recovered a lot of time. And see you on Wednesday. Thanks a lot.
Our apologies for starting late. As everybody's found out, we're a bit more ad hoc in this group. Mobile ad hoc networks. Yeah, when you initially said, is it MAN-A or MAN-IT?